I'm Emily Porter. I'm a digital repository program manager at the Emory Libraries, and I'm here with Beth Crumpton, who's our senior operating system administrator. You here, Beth?
I am.
Great. So as others have done, I want to reference rather than read in its entirety Emory University's land acknowledgement, but this is included in our slide, and there's a link to it as well. So we're going to just kind of give a little tour of how we've done fixity checking in a couple of different ways over the last few years. And to start with, this is sort of an overview of version 1 and what we started with. We launched a Hierarch 3 based curation application in 2019. It has a Fedora 4 backend, but we do store our files externally in S3 rather than in Fedora itself. We also have a second bucket, which is a copy of the first as a second preservation copy. As part of our Hierarch ingest, all files that are ingested get a SHA-1 checksum, and that is what the Fedora fixity service is using. And we've customized our application so that we can either kind of press a nice little button on a file set page to kick off the Fedora fixity service for a single file set on demand. But we also have the ability to build up a queue and run a batch of file sets that haven't had a check in the last 60 days. We also have another preservation customization where we store those sort of outcomes of those check events as little sub-objects that get attached to file sets in Fedora, and they're also indexed in Solr so that we can do nice things like display them in the interface. So there's just kind of a little truncated screenshot of what that looks like for version 1. And it's also tracking the version of software that was used to run the check. Get the slide to advance. So version 1, it works. And we were pretty happy with it. It ticked a lot of the boxes. It did a lot of things, and it was a lot of work to get that up and running. But as our inventory began to grow, and we were running more of these kind of bulk queued checks every few months, we started to hit S3 request throttling, which led to a bunch of false failures, essentially. So we had to kind of go back and rebuild the service so that it would only check one SHA-1 at a time. Unfortunately, that was taking about 30 seconds or more for each file. And as our inventory grew, and in fact, the last time we ran this particular bulk approach, it took over 4 weeks to complete, which is clearly not efficient, not going to work. Ingest and other background processes couldn't be run at the same time because we were experiencing degradation across all processes. And as I noted before, we have 2 preservation copies of files, but Fedora only knows about one of them. So that check is only checking the first bucket. And where we are now, we're over, well over 500,000 files in S3 times 2, and that's increasing every day. So Thinking Cat had some thoughts about what to do. And we needed to ask ourselves some questions like, is there a better way to do this? Can we do something in AWS itself, a more AWS native option? And that led us to a series of investigations, kind of trying to peek under the hood at what does Amazon actually do to ensure file integrity in S3? And that's a little bit of a black box, but we did find some solution papers in there that were relevant and interesting and gave us some insights. We also had to determine what our institution's managed AWS offering would allow, because we don't necessarily have access to the full service catalog. We wanted to be able to check fixity for an entire bucket. We also wanted to be able to check it on a subset of files as desired. We were hoping that this is something that a repository manager could run in a user interface. And then we really wondered, well, what would these check results actually come back looking like? And then ultimately, how much is this going to cost to run? Because once you start kind of layering on new tools and in this transactional model, it's really hard to tell. We saw some cost examples, but they weren't really relevant to what we needed to do. So we decided to kick the tires on this and do a pilot. And now I'm going to hand it over to Beth.
Hi, thank you, Emily. So AWS has some things that will make this a little easier. One of them is a state machine that just does fixity checking for you. And you can get this from a publicly available CloudFormation template. So that's lovely. Now, this state machine checks individual files, and we have an entire bucket full of a whole lot of files. So what AWS provides for us is what they call batch jobs, which are jobs that you can invoke on any subset of the bucket, including the entire bucket. And you can then take each file and send it off to a Lambda function. And what we can do in this Lambda function is then send each file off to this fixity state machine. And then the fixity state machine will tell the Lambda function, okay, did this succeed or fail? And then the Lambda function can return that success or failure on back to the batch job. And then it gets recorded automatically. And this is a little bit circuitous, but it works, and it works very well, especially in our somewhat limited AWS implementation. Can you move to the next slide, please? So, like I mentioned, we return the results back to the batch job, and S3 batch jobs will record results for everything it does, just kind of for free, and in a CSV report that ends up in another S3 bucket. And this is nice and convenient, but the format is somewhat set, and there's a limited amount of things you can do with it. And it's an okay format, but it's not the best format for Emily's purposes for reasons that she'll discuss in the next slide. And I have some basic skills and delusions of grandeur, so I can make this better. What I can do is I can use AWS events to monitor my S3 buckets for the creation of these batch job reports. And when it sees one of these batch jobs reports getting created, it sends those off to a whole nother Lambda function, which takes in the CSV, reformats it, rewrites it to anything we want, because it's just a CSV file and I know Python. And then it takes whatever format Emily wants at the end, and it sends it off to us via just AWS SNS. And that, in a nutshell, is how we're doing all of this.
Thank you.
Back to you, Emily.
So we're running short on time, but I'll try to get through the last few slides. Version 2, it works, and it's really fast. We are absolutely thrilled. We ran it in production on an entire bucket, and it ran in 24 hours instead of 4 weeks. So it's really significant for us. But there were a few things that we needed to tweak. One was, now that we've changed our process, how are we going to know which file sets haven't had a fixity check, since it's now kind of happening outside of our Fedora infrastructure? We also needed a way to kind of make sure that we could trace a SHA-1 back to its file set. And we also really wanted to get the data back into Fedora, since Fedora is our system of record for metadata. And here you can see that nicely reformatted CSV template that Beth was just describing. And this, we designed it to very closely match the structure of the preservation events that we record. So that leads us to version 2.1, round trip back to Fedora. So thanks to our software engineering team, we now have a task that can load that fixity data from those CSVs back into Fedora. They're indexed in Solr. And we have a nice UI that allows me to go in, click a button, upload the CSV, and load it back in. And also our just Hierarchs users can go see those new events. You can see 2 rows on my screen here. One is an example of the Fedora report, and one is an example of the serverless fixity. And users can still run that on-demand check using Fedora. So I'm thrilled about this. So additional thanks to Catherine Michaelis, Brad Watson, Alex Zotoff, Devanshu Matlawala for helping us get from version 1 and version 2. And Beth and I would also like to thank our respective team of cats who supervise us very closely as we work from home. We have some additional notes in our slide deck, which you all can review later, but that includes information about how much it costs to run, and also some links to some of our code. So thank you very much.